Hello everyone, welcome you all to another video on graph theory. In this video, we will be discussing about the two major types of graph. There are many types of graphs are there which we will discuss in subsequent videos, but in this video we will be discussing two main types. One is the undirected graph, another is the directed graph. Because in most cases we encounter this type of graphs, undirected as well as directed graphs. So what is directed and undirected graph? Let's see with an example. So suppose we are having a graph, say 1, 2, 3, 4 and 5. So these are the defined vertices as we have discussed in the previous video, and these are the different edges that connect those vertices. Now here we observe that as the name suggests, directed means there will be some direction within the edges. However, undirected means there is no such direction. For example, here we can take, if you observe this path or this edge, here we see that this edge can be used for a person to travel from location 1 to location 2. Similarly, the same path can be used to move from location 2 to location 1. So this is considered as undirected. So no direction is associated with a graph, with the edges. So this is called undirected. However, so this is the example of undirected. However, if we have another graph, say 4 and 5, and in this we have something of this type. So such type of graph is considered as directed graph. So this is the basic difference between undirected and directed graph. In undirected graph, there is no direction associated with the edges. However, in case of directed graph, there is a direction associated with the edges. So if we speak here, so to move from 1 to 2 means we can say that there is a edge 1, 2. However, and similarly we have an edge 2, 1 also, because the same path can be used. However, in this case, if you observe, we can move from 1 to 2, but there is no edge that will take a person from 2 to 1. So there is no such edge. However, 1 to 2 there is an edge. Similarly, 1 to 3 there is an edge, but no edge is from 3 to 1. So this is the difference between directed and undirected graph. Now, where is the concept of directed graph used? We have observed there are some lanes in highways through which we can go, but we cannot come. Similarly, there are roads which we can come, but we can't go. So those follow the concept of directed graph. Now, since this is used to go from 1 to 2. If someone has to reach 4, how can they reach? So they have to reach from 1 to 3, then 3 to 4. But they can't go via this. However, in this case, since there is no direction associated, so they can directly move from 1, 3, 4, 1 to 4. So if we are asked, what are the paths from 1 to 4? We can say it is 1, 3, 3, 4. Any more? No. So only one path is there. So this is about the directed graph and undirected graph. Now, while discussing this directed and undirected graph, several concepts come here. So one major concept is source and sink. So what is the meaning of source and sink? So source means, if you observe carefully from this graph, on this graph you see that the node 2 or the vertex 2 has no outgoing edge. There is no outgoing edge from 2. So there is no outgoing edge from 2. Similarly, if you observe node 1, there is no incoming edge to 1. So from 1 we can go to 2, from 1 we can go to 3, but no node can or has any edge that is going to 1. So this 2 is considered as sink. The vertex 2 is considered as sink, and this vertex 1 is considered as source. So in case of directed graph, the source and sink refers to a vertex from which or into which there is no incoming edge. However, sink is a vertex in which there is no outgoing edge. So that is all about source and sink. So associated with source and sink, there are two more terms that are required. One is in degree, another is out degree. So for every node we have in degree and out degree. Now what is in degree and out degree? So if you observe for the node 1, the in degree for node 1 is how many nodes have edges that are coming to 1. So for 1 there is no such edge, so it is in degree is 0. So we will be using in the term in degree. In degree of 1 is 0. In degree of 2, if you observe properly, for the node 2 there is 3 in degrees. So 3 in degree for node 3. So for node 3, how many in degrees are there? 1. However, there are 2 out degrees. So in degree is 1. In degree for node 4, 1 is in degree, so it is 1. Similarly, in degree for node 5 is 2. Similarly, if we find the out degree of node 1. So what is the out degree for node 1? From node 1 everything is going outside. So two edges are there. So it is 2. Out degree for node 2. Out degree for node 2 is 0. So there is no out degree. From 2 we can't go anywhere. So therefore it is 0. Similarly, out degree for node 3, there are 2 out degrees. So 2 means from 3 we can go to 2 places. So 3, out degree of 3 is 2. Out degree of 4, from 4 we can go to 2 and we can go to 5. So that means the out degree for 4 is 2. So out degree of 4 is 2. And what is the out degree for 5? From 5 we can go to 2. That means there is 1 out degree. So 1 out degree. So this is all about in degree and out degree. In degree means the number of edges that are coming into that particular node, and out degree means the number of edges that are going out from that particular node. So now if you observe carefully, what is 1? It is source. What is 2? It is the sink node or sink vertex. Now if you observe carefully, the in degree of 1 is 0. However, out degree of 2 is also 0. So means for what is 1? For source. For the source, the in degree will be 0. However, for sink, since 2 is a sink, so its out degree will be 0. So that is the link between source and sink. So out degree of sink will always be 0. In degree of source will always be equal to 0. So this is the concept behind undirected graph and directed graph. We will be using these concepts in further suppose traveling salesman problem, Dijkstra's algorithm, and all this. We will be using these concepts. So I hope the concept of directed graph and undirected graph is clear. So in the next video we will try to discuss all the other different types of graphs. There are many other types of graphs, regular graph, complete graph, and many more. So we will discuss all these in the next video. Thank you all.